Founded in 1967, Kimley Horn is a full-service, employee-owned, multidisciplinary consulting firm offering a broad range of engineering, planning, landscape architecture, and environmental services to clients in both the public and private sectors. With more than 7,000 employees in 100 offices across the United States and in Puerto Rico, Kimley Horn is a national leader in sustainable development and provides innovative, implementable solutions. And thank you to Kimley Horn for sponsoring this presentation. Good afternoon, everyone. My name is Sam Schwartz, and I'm the Director of Marketing for the Energy Management Association. Thank you so much for joining us for another EMA webinar. As usual, I'm just going to go over a few housekeeping notes before we get started. The presenter will be periodically monitoring the questions that come in, but we're going to be holding them till the end for a Q&A session. But if you have questions, we do encourage you to submit them as they come up to that Q&A button at the bottom of your screen. If you happen to be experiencing any technical issues during the webinar, please use the chat function to inform the panelists, and our technical experts will assist you. This presentation is being recorded and will be available for viewing in 1 week for credit. And then finally, in terms of continuing education credit, everyone in attendance for the full webinar will receive a certificate of attendance sent to their email within 24 hours. So today's webinar is Decarbonization for Dummies with LaPera, who is an EMA board member and actually does training for the EMP seminar. He has near 45 years of experience. He's worked on a broad range of building types, including educational, healthcare, commercial facilities. He's well-versed in the design and analysis of HVAC systems and providing engineering services, including planning, analysis, and construction observation from project conception through construction administration. And his focus is on systems commissioning, energy analysis, and energy auditing. So perfect for today. Al, do you want to get us started?
Sure. Thanks, Sam. I appreciate that. All right. So welcome to Happy New Year to everybody. And what we're going to talk about today is decarbonization for dummies. And I am the primary dummy here. How this whole thing kind of came about was I was supposed to do a presentation to the AIA here locally in Tampa, and I was tasked with doing this thing for decarbonization. So I started to look into it, and I was like, as I affectionately call it, cramming for the exam, so to speak. And I started to realize that I did not know as much as I thought I knew about decarbonization. Being involved in doing energy savings, that was something I dedicated probably the last 15 years of my life to try and reduce energy consumption. And that was basically what you'll hear from this point forward is operational carbon. And so I was like, okay, I got this operation. I know all about that. Well, then I started to realize this thing called embodied carbon. And boy, did I feel like a dummy that I didn't understand that. And when I went and I started talking to my peers, I found that, guess what? I wasn't alone. So this whole thing kind of started out from me not knowing. And then it's a shameful plug. There'll be in engineered systems, it's going to be an article similar to this, and is what made me write it, because I think that I'm not the only one. So I wanted to bring, maybe everybody out there is a lot smarter than me, and they probably are, but I wanted to let everybody know that, we should know about this. And I think that I always like to start my presentations off with quotes, and I thought this quote was really a perfect one for this. This came from John F. Kennedy, where he was talking about to go to the moon. That we do these things not because they are easy, because they are hard. And I think for us to help save the planet and continue to save energy for our children's 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 children, we have to think about these things. So I thought that this became a good mantra going forward. We're going to talk about quickly is we're going to define what decarbonization is. We're going to use the key approaches. We're going to employ what beneficial electrification is to reduce building operational carbon dioxide. And then we're going to talk about how you design buildings to get there. So we're going to do with some definitions. So let's talk about what is carbon. Carbon is greenhouse gas emissions. And wow, what are greenhouse gas emissions? They are basically the global warming potential. Okay. And, you know, again, if we start to think about a greenhouse gas emission is something that's going to hold the heat down onto the earth, which that's where all this whole idea of this global warming and is coming into effect. And then we're going to start talking about this in carbon dioxide in metric tons. And then we're going to look at, you know, the 20-year versus global warming potential versus a 10-year, and then what our current challenges are. Again, I'm not sitting here going to tell you that the world is coming to an end or anything. I just think we have to be cognizant of what's going on, is that I don't care which side of this fence that you all sit on, whether you think it's all man-made or you all think it's you know, Mother Nature, but you know, I think, you know, either way, we need to help. We have to help our mother out. I guess the best way I'm looking at it. And this is what this is all about. So we all educated people that we're all in this together. So I think we need to talk about it. So let's just talk about some simple definitions. What is decarbonization? Okay, it's the journey and the destination. You know, it almost sounds like a song that the Eagles might have wrote, right? But basically what you're talking about is the reducing and eliminating embodied and operational carbon, you know, which we should first start to define what is embodied carbon. Embodied carbon is the carbon that is associated with the building construction, which is including the extraction of material, manufacturing of that material, the transportation of that material to the building site, and then literally its ultimate demolition. So it's like, you know, cradle to grave, if you really want to think of it that way. And operational carbon is pretty much what you would think. It is the carbon that is being used to operate the facility throughout its lifetime, right? So hence why I completely was enamored with that thing, because I want to reduce energy in a building. It's what I literally wake up every day to try and do a better job at. And so I go, that I understood. And then there's one thing called net zero, is basically after you've reduced the amount of zero carbons that you can get into the building, right? That you're emitting the minimum amount. How do you then get it to zero? And that there is usually by doing some sort of sequestration or or some other way of doing it, right? Okay. So let's go on here and let's talk about. We're going to do a quick pop quiz. Sim, there we go. So list the order of greenhouse gas emitters by sector from least to greatest. Yeah, I know this is something you're going to go, yeah, you didn't settle up on trying to do this, right? So I'll leave it over here so it's easier for you to see. All right, let's see what everybody thinks. Okay, well, there is no clear winner in all of this, which I think is just kind of interesting. And again, you know, because it kind of shows how people are not completely understanding what's going on. So, but what we found is that with this is building materials at 22.7%, transportation at 23%, and building operations at 28%. So that there is, you know, so you have an idea of where they're all coming from, right? So you can see why that whole embodied carbon cradle to grave thing is, where you can see where transportation and then building materials are a big part of it. All right. The embodied carbon, right, when we start to look at it, is that, you know, this is where I think I started to get a complete understanding of what was going on, right? The embodied carbon is like, where did you produce it? And those emissions that are coming out at the factory, the trucks, the planes, railway, however way they're getting the material to the site, the actual construction site that's going on, there's the work, and that is it. That is a true way embodied carbon is. And then there is operational carbon. I hate to say it, traditionally MEP and architects have been focused on lowering operational carbon, but not the embodied carbon. We're starting to see it more and more, and as we go along, you'll see more items that are showing you where we're starting to turn it. Now, this is not a new thing at all. People have been talking about this issue of embodied and operational or decarbonization probably since the early 2000s, probably about 2008, 2009. So we're going to talk about a little bit about net zero, okay? Now, this is a step process, right? First, you reduce the amount of emissions that are coming from the building. You make them as efficient as you can. You put on solar PV onto the building. You do what you can to reduce it. And then you do things by removing it after, right? So there are two different ways of doing it. You can do it with biogenic sequestration, or you can do it with direct air capture, right? Biogenic sequestration is basically uses plants through photosynthesis to be able to remove carbon naturally out of the air, right? That's one way to do it. And then there are what do you call carbon, this direct air capture, which is another way of doing, which is a modern technology, which grabs the CO2 out of the air into something that could be converted into a form that could be sequestered later, which is sequestering is taking it out of the air and not readmit it, right? But I just want to make it really clear that this direct air capture is not a cost-effective way to do it. Basically, the last time I looked, which was about a month ago, that biogenic CO2 costs in a range between $15 a ton of CO2 to $30 a ton of CO2, where this direct air capture is anywhere from $135 a CO2 ton of CO2 to $345 for CO2. Again, it's coming down. When I first looked at this, almost 6 or 8 months ago, those numbers were anywhere between 250 and 600. So it's coming down. But the point of what I'm saying is that there is, we have to, pay attention to it. So it can be done, and that is the one thing. We have the greatest minds in this world, and they're in this country, and they're going to figure it out. I have no doubt about it. We just got to be all on the same page going forward. I thought this was kind of interesting, right? Let's define what is a 1 metric ton, right? So I saw this image of a 33-foot round ball as a sphere, right? And that's what a metric ton of carbon dioxide gas is, right? So let's talk about what emits out a cubic metric ton of CO2. 110 gallons of gas consumed, and that's, think about it, that's like driving a Humvee and making probably 3 fill-ups because they only get like 15 miles to the gallon, right? You could burn 1,100 pounds of coal. There's 188 therms of natural gas is burned, or basically 40 barbecue propane cylinders consumed, basically emits 1 metric ton of CO2. How you can avoid it is you can do 40 trash bags of waste and instead of a landfill. And what happens with those there are put into bio digesters, right? And which you can, and that can then be used as energy. Then you have 40 incandescent lamps switched to LEDs. And now, how could you sequester it, right? You can now sequester it by that 1 million, what do you call, a metric ton of CO2. You can sequester it with having 16 tree seedlings growing for 10 years or 1.2 acres of forest in 1 year. Well, before everybody starts dancing around thinking that we could plant our way out of this problem, a power plant uses a metric ton of CO2 in the blink of an eye. Okay, so let's be really clear that this is not an easy way to do that. Now, all this data, and you'll be getting all this, this PowerPoint, I sent a copy of this PowerPoint at the end, and I've put in where you can go and find where I got this from the calculator. So you can, this is meant to be more informative so you can find out and learn like I did. Global warming impact, okay. The greenhouse gas emissions, that is our 20-year impact. And basically, when we start to look at where all this is coming from, is, 26% is coming from methane, which is basically natural gas. We have 6% is coming from nitrous oxide. You say, well, nitrous oxide, that's what you go to the doctor. But what happens with that, that is a gas that you consume into your body, and then you emit it and it goes up into the atmosphere. And then you got 2% of fluoride gases, which are basically refrigerants that you have to worry about that is going out into the atmosphere. Now we're going to start talking about how we're going to reduce the embodied carbon, because I think we have an understanding how to reduce the operational carbon, but let's talk about the embodied carbon. And this is when I went and gone through all of this, is where I was so totally surprised at what I didn't know. And that's where, again, I keep going back to, it's like you realize what you don't know what you don't know, right? I've said to people that have worked for me, they've heard me say that a million times. Sometimes you don't know what you don't know. And this was one of those things, at least for me, that I didn't know. And so, the 2030 challenge folks, Architecture 2030, they've been following this for a while. And I thought this was kind of interesting. If you look at buildings, business as usual projection, that the embodied carbon after 30 years, it was still 49% of the overall carbon consumed by a building. I thought that just kind of blew me away, right? And when you start to look at it, when you go to this slide, when you look at the time value of the embodied carbon and you start to look at this, the embodied carbon stays kind of constant over the life, and you have a ramp up. But if you look at it, year 10, assuming that the building was constructed in year 2020, in 2030, the embodied carbon still made up 74% of the total carbon that was consumed in that building in the first 10 years. So I think you start to see why we have to, pay attention to the embodied carbon of a building. And so where's the embodied carbon coming from? 10% comes for transportation to construction. 10% is the MEP stuff going in. There's the cladding on the buildings. But the big one that you see here is the superstructure. We're at 42%. But how can we help to reduce it? So if we start to think about how we can help, when we look at the MEP folks out there, how do you help? Well, we help by trying to not put the heavy stuff on top of the building, so the structural brethren don't have to put as much concrete and steel into the building. That's one way of looking at it. the architects, I realize that I'm going to be talking about blasphemy right here when I say you guys need to really put less glass in the building, right? And because there is, because how they're going to reduce it, and you'll see in another slide where I talk about it, is that they want to reduce. There's a lot of embodied carbon in the cladding of a building, right? So that's where it is. But the big thing that I was really surprised, and you'll see this in the next couple of slides, of where the superstructure, a lot of it comes from foundations and the superstructure. You'll see, which was done by a great study by Thornton Tomasetti. Thornton Tomasetti showed here that where a lot of it came from. And I think what you'll see, which I think is just really kind of interesting, that you'll see that a lot of it has come from the floors in mixed use and labs. But you can see with all the green that a biggest portion of it comes from the floor slabs themselves. So it's kind of amazing of what it is. And you're going to start to see that there is going to have a shift. You've already seen it in the code, where the code is now starting to allow for timber construction, even in, I won't call them high rises, but there's been definitely a shift to allow for heavy timber construction, because it's already sequestered carbon when you use wood. Now, understand, while it has been sequestered, it puts off a tremendous amount of carbon when God forbid the building ever goes up in flames. So we have to understand that there's no free lunch for anything in this world. The other thing here where is the embodied carbon, this also came out of a Thornton Tomasetti thing, is that this just made it a little bit more graphic to show by which sector, whether it was commercial, education, or domestic, where all the embodied carbon was in the building. I just thought it was just fascinating, at least to me. Then when you start to look at it, is like, where are some of these things that are high in embodied carbon, right? So what this is you look at that, 11.5 tons of CO2 is for every 1 metric ton of carbon, right? So I just think it's fascinating that you start to see everything has embodied carbon involved in it. Some things have more that get emitted into the atmosphere, and that's where the issues of global warming potential, when we were talking about it, is like where you get from refrigerants. This is a way, you're talking about how can you reduce it, and you've seen these in many, many studies, that if you start from the beginning and you start to figure out how you're going to reduce the embodied carbon in a building, you got to start with the end in mind, and how you're going to get there, right? You start from planning, and so it starts to talk about, and I blew this up a little bit here better to show it here, is that you build either nothing or less, which is an adaptive reuse of existing buildings, and use existing assets more efficiently. But if you go back to the Architecture 2030, they made it really clear in their analysis that by the year 2040, that 2/3 of the global building stock of buildings that exist today are gonna need upgrades, and they're gonna be existing buildings, right? That a majority of our buildings today were built prior to the 1980s, right? Most of the buildings they need to be updated, and the best thing, we've already spent all that energy on the glass, on the concrete, the steel. It's already in those buildings, so we should reuse them, right? The other thing, build effectively, which is optimize the structural design, like I talked about. Like I said about doing structural, by doing like heavy timber is one way to do it. There are a lot of firms out there now. Actually, we can help with that. That you can do life cycle analysis on which is the best over the life of the building, that you can reduce the amount of carbon going into the building and specify low carbon or carbon positive materials, right? You could build efficiently, and one of the ways that they've talked about doing this is incorporating into building better practices as no idling policy on job sites. Now, how many of you've passed a job site and you'll see this parade of trucks sitting there and they're just dieseling while they're waiting to get into the site or whatever. So, but if they're going to wait over a certain period of time, that's one way you can reduce stuff going up into the atmosphere. All right, we're going to go into number 2 here. All right, Ned owns an electric vehicle and brags to his coworkers that he has reduced the greenhouse gas emissions. Tatiana points out to him that he plugs his car into the electric grid and his utility company runs on natural gas, which is a great emitter of greenhouse gas emissions, right? So Carl is also mentioning that lithium is difficult to mine and its extraction is damaging to the environment. Tatiana's comment is an example of what? What is she talking about here? So we're talking about, is she talking about embodied carbon, operational carbon, scope 1 emissions, scope 2 emissions, or scope 3 emissions? All right, let's see what everybody thinks. It's really 2 answers here that it could be, by the way. So I'll give you a shot at. All right. Most of you were correct that it is operational carbon, but it's operational and scope 2 emissions. So those are the things that are part of that. Now, here's another term that we keep hearing about all the time: beneficial electrification, right? How are we going to get there? And everybody should be on electric cars and so on. And how are we going to get there? There is a lot of things about electrification, right? So I thought this was a great little way of looking at it, is that, that you try to get your building off it, and basically you're replacing the fossil fuels. But, there is, when we start talking about, can we really get there or not? I think there's a lot of discussion of whether the grid can support all of this, of people having electric cars. And I can tell you right now, if you went online and you Googled, can the electric grid today support everybody having an electric vehicle, you will find, I don't know if it's an equal split, but you'll find a reasonable split of people that are on both sides of this fence, and both of them are experts. So if I was going to take, and I always like to take the middle of the road on things like that, because there's no defined. Everybody said yes, then it'll be one thing. I think that in some places it can be, in some places that it can't, and that's what I would think. But this is where it has to go, and we'll start talking about why we should start looking at upgrading the grid, and that is one thing that people have started to see. You're starting to see more and more people putting in solar PV on their homes. You're seeing the rise of microgrids, and even the utility company is putting in microgrids, whether it's wind or solar or geothermal. They're putting them in. There are 2 sources of operational greenhouse gases from building, and they're from electricity, right? That there is, one comes from the power plants, and obviously, which is powered off of, and the other comes from fossil fuels that go to homes, right? So, there are ways that we have to reduce that. And so I'm going to show you like a simple path of what I'm saying that how we have to get there. The typical path, the way we see it now, traditionally buildings right now, they are served with both natural gas. Not every building. Here in Florida, we don't have a lot of natural gas going into buildings unless they're there for the kitchens only, but they're not heating the buildings traditionally with them because we're a cooling dominant environment, which is completely opposite if you're in Wyoming or in North Dakota or New York or Illinois or so on. It depends on where you are in the country as of where this applies, but this is just to show you generally how would you do this. Is that we're saying that the typical building now, if you're heating it with natural gas and electricity, an efficient building is going to less windows, right? That's staying as things as the way they are today, but only putting in less glass. That's where I was talking about the architects who love glass. And don't get me wrong, you can see behind me, I have a lot of glass in my window and I really do enjoy it. But I think that reduction of glass and putting it in prudently is a better way to go because it reduces the operational carbon because you will be putting less capacity or tonnage, which is taking less off the grid. In warming dominant climates, it'll be less heating that's required. But so the first step is to reduce the windows, things as they are, then going to an all electric building with reduced windows, and then a fully decarbonized building is partially off the grid, using wind, solar on the building. There is many ways on how to get there, but it's a gradual process on how we should get there. So I'm going to give you some quick, example of a heating switch over electric resistance heat to heat pumps. Okay, this is real simple. This is real simple math. So we're going to take a building. The building heating is 350 MVH, which is 100 kW roughly, which is 100 kW resistance heat. If we did it with a heat pump, and heat pump that has a COP, which is coefficient of performance. And what that means for everybody that doesn't understand what coefficients of performance means is that if I'm using 1 kW in to the heat pump, it's actually putting 3 kW out. So in theory, with a COP of 3, if I put in 3, instead of needing 100 kW, I only need 33 kW, right? I think that's pretty simple of why going with heat pumps is simple. And that's based on equipment over 65,000 BTUs, which is 5 tons. And actually the code actually is 3.3, but for this, to make math simple here, I did it this way. But then at the power plant, right? Now understand, at the building is source energy. At the plant is I should take that back, apologize. At the building, it's site energy, and at the power plant, it's the source energy. Now, if we look at electric resistance heat, and you basically are going to burn to create that 100 kW, we're going to use 1,500 pounds of CO2 per hour to get there. We're going to burn it into the atmosphere. By that reduction, we're going to reduce it to 500. Okay, does that make sense to everybody? Now, just for kicks and giggles, I went ahead and I did that. If we did the same building, but there was a series of smaller heat pumps in there, which are less than 65,000 BTUs based on the 2023 code that just went into effect for energy conservation, which now had a COP of 8.8. So basically, we would now, instead of needing 100 kW, we would only need 11 kW versus the 33. So I cut that by a third. And then at the power plant, instead of needing 1,500 pounds of CO2 per hour, we only needed 166. So I just thought that was just an interesting way of taking a look at it. Another thing we can do is if we start to switch over to natural gas has a tendency to have some leaking, that if we use natural gas, you would use for that same 350, we would have 440 MBH that's being consumed versus the 33 kW, and that the natural gas, which is just 500 pounds of CO2 combustion, and the heat put is C. So they're about equal, but that doesn't take into account that the percentage of leakage in other than of the 400 pounds of CO2 of the methane that's going to happen. All right, and this is the last and final quiz for today. All right, where is embodied carbon mentioned? The Inflation Reduction Act, is it mentioned in Architecture 2030? Is it mentioned in the AIA, and that's Architect Institute of America, by the way, Framework for Design Excellence? Is it mentioned in the Structural Engineering Institute 2050 Committing to Zero, or all of the above? Bet you this is an easy one for everybody to get. What does everybody think? All right, so 88% of you got it correct. It is all of the above. All right, the last thing is, how do you get there in building performance, right? There's 3 ways, we can concern with the actual greenhouse division. We should focus on the actual building performance. That's one way, and not how it's designed to perform, right? We can have alternative to energy code reviews and inspections, which are not often very vigorous or applied. And as communities and companies establish their own carbon measures that could be done. Well, I can tell you right now, we have a influx of states and cities that are taking this, whether it's right or wrong, I'll leave that to other people to opine. But we're starting to see where building performance standards are being applied. I can tell you right now, the state of Washington has enacted that by the year 2025, that they have the buildings of a certain size, and they're doing it graduated. I think the first size is buildings, I want to say up to 150,000 square feet or 200,000 square feet, something like that. This is office buildings. They have to meet a certain EUI or KBTU per square foot by the year 2025. If they don't meet it, then they get fined. I don't know if it's yearly or monthly, or until they get it fixed. And then the following year is the next size in buildings, and so on. Then you get New York City, which has enacted local law 97, which by the year 2025, and they, instead of going by KBTU per square foot, they're going by establishing it based on metric tons of consumption that is being emitted into the air, that the building, I should say, that's being consumed by the building. And by 2025, that they're going to also start to be, and that I think is all buildings, and they're going to get a fine. And then if they don't get it fixed by 2030, the fine goes up, and so on. But again, you have to start thinking about it. And so, people are starting to take it, into their own hands, in a sense of whether it's right or wrong, whether we should, stop using fossil fuel for everything, and so on and so forth. I'm going to leave that to others. I would prefer to stay away from that. I hate to say it, the political football of the life we have these days, but I think we have to figure out, because we are going to run out of natural resources, regardless of how you feel about anything. So reduction, clean water, or reducing consuming energy in the building, all of that just plays that, like I said, my children's 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 children will have clean water and power and energy, and the sun will still be able to shine because we're not clouding it up. So I think it's a good idea to do this, and we're starting to see more and more of these establishments, and some codes are starting to mandate it. One of the other things that the embodied carbon in the Inflation Reduction Act was mentioned in many, many places. I'm not going to read into this, but there is a series of many places of where you'll see that money is going to be spent to reduce it and make buildings more efficient and greener. A lot of it is going to start to happen within the federal government itself, but there are different grants that are going to be made available for other buildings to reduce. We're also, I think everybody's starting to look into it to see how they can help their clients out. And with that, I'm going to open it up for questions. I hope there's people, bunch of you have a lot of questions out there. And I'm going to tell you again that I, for and foremost, am not an expert on this. I'm learning, like I think a lot of you are. And if some of you have some, if what you want to bring up is a place where we can all learn something, feel free to bring it up. We're all here to learn. And, as my dad told me when I was a little boy, that one hand washes the other and both hands wash the face. And that's how I see how we can get this done, because, we have some of the greatest minds in this country, and if we work together, we can make this happen. So Sam, what do we got cooking from people and questions?
Okay, let me start off here. And if anyone else has any more questions, feel free to submit them to that Q&A button you see at the bottom of your screen. So Al, shouldn't the COP be rated as the outside temperature drops?
Well, that does. It does happen as the outside air temperature drops, but they're making the heat pumps even more efficient, where I remember it was common that heat pumps operated down to, I think it was, if I remember, when I first came out, you shouldn't use them below 47 or 45 degrees, and now, and most recently they went down to 35, and now they're talking about that they're able to get some energy, not as much, out of the air down to almost 0 degrees, which is fascinating. But yes, it does get derated. But again, this was meant to saying we should start looking at it as a means of being able to do it. Again, this, I'm not preaching a panacea here by using a heat pump. I'm just showing in many instances that is a way to do it. Does it mean that it is the solve everything? No, there's going to be a time when you have to go through a defrost cycle. For everybody out there that doesn't understand what a defrost cycle, the air conditioning unit, right, is taking heat out of the air. When your normal air conditioning unit is taking heat from your space and rejecting it outside, when it's a heat pump, heat pump is taking it from outside and rejecting it in. At some point, your condensing unit outside, that's the unit outside, is going to turn into a block of ice. Believe me, I've seen it happen. And when that happens, it reverses itself back to an air conditioning unit, and so it can defrost itself. You don't want dumping 50-degree air back into the building, so electric resistance heat is never going to completely go away, but it is a means of being able to handle it. Hope that answered that person's question.
Thank you, Al. Next question's asking, in your opinion, how much of an impact on decarbonization would a shift from work from home versus work at the office culture mean?
Well, that now you're getting into. We saw during the pandemic. It was obvious during the pandemic. We saw that our the skies got cleaner, right? Because people were driving less. They were using their cars less. So from that perspective, if we purely look at it from that, then working from home is potentially a better thing to do if we look at it for emitting, CO from your tailpipe into the atmosphere and doing that. But then you're going to be using more energy at home versus at work. And then you have to look at, then you're going to get into the philosophy, which I want to stay out of. I'm just going to say we're starting to see the whole thing of the working from home, whether it's really healthy for everybody, whether it's really productive for everybody. And I'll leave the experts to opine on that. But I think it's, I think there's pros and cons to all of them. And maybe there's which I think we're starting to see now, is that a healthy balance between the two. Working from home, clearly, think about this prior to the pandemic. If people got sick or didn't feel right, they came to work anyway because they didn't want to give up a sick day, right? Well, now they can work efficiently from home on those days. So like I said, I think we're going to have I think we can come with a healthy balance of where we are producing well for our economy and ourselves, and a healthy way to go. Okay, I hope that answers everybody's question.
Thank you, Al. About 3 more questions here. How can embodied carbon be measured? After a building is finished and occupied, why does your bar chart show continued embodied carbon emitted?
The way I understand that, and again, I'm still learning. That's a great question. I wish I can go and Google it right now to give you the right answer, candidly. But I think that has to do with that. There is so much that has been put in to produce it, right, and build a building, and that they've just averaged it, is what I think it is. Okay, instead of saying you use this gazillion tons of carbon day one in the building and you did it in a year, I think this is. I don't know that this is the answer. This is what I believe the answer is that all they did is, and that's why you see it as an average, is that they average it over 30 years, the total consumption to build and construct the building. That's my story, and I'm sticking to
it. Thank you, Al. A lot more questions came in, so I'm glad we have time. Someone is asking if a portfolio manager is being updated to include net zero planning features. I'm not familiar with any updates on that. Do you, Al?
No, I'm not, but I wouldn't be surprised. Again, if you think about it, it has taken almost 11 to 13 years, right, for decarbonization to become a commonplace discussion. And by the amount of people that wanted to be on this webinar alone, and God, I wish I was smarter and could teach you more, that it's not known. And I mean, we can go back, we can think about that. LEED buildings, we can now start to talk about that with health and wellness in buildings, right? Health and wellness in buildings. The well building standard has been around, I'll say probably now 6-7 years, and maybe even close to 10. And it didn't start to take hold, or anybody cared about health and wellness in buildings until the pandemic, right? So it's taking its time to get there. So I'm sure that Energy Star will get on the bandwagon. I hate to say it that way, meaning that it's a bad thing. I think they're going to get on that bandwagon and start to and have that, especially with places like New York and Local Law 97 talking about it being viewed in embodied in carbon emissions. All right, next.
Thanks, Al. Another question about glass. If glass is a problem, how are architects supposed to allow natural light through buildings? They're assuming that the alternative glass windows and elements would be plastic based.
Well, no,
Building
what I
materials.
think what I was trying to say there is, look, while I had the fortunate pleasure of working with Ian Pei when I was way younger than I am today. That man loved glass, and I've worked with many architects that think of that having minimalistic glass is blasphemy. So what I mean is that there should be a reasonable level, and this is where you can talk to your engineers and they can do lighting autonomy. You bring in you use the correct amount of glass where you start getting more, it has good light transmission into the space. You can effectively use glass. That, I think, is the point that I was trying to drive at. Instead of having tons of glass, you limit it. That's all. I'm not saying not to get rid of it. Glass is what makes it. I'll be the first one. I am a reformed or recovering architect. My original degree was in architecture, so I love glass. I love all glass buildings. But the engineer in me realizes that that is not good for the environment. Think about how much aluminum is done in cladding and how bad aluminum is for carbon that's being emitted. So the point is that I just think that it has to be a healthy balance. I'm not saying to get rid of it. I'm not saying to use plastic windows or anything like that. I'm just saying that this is, and again, this is my opinion too. Again, and there's other people who are going to go, screw it, we're going to put all the glass in, who cares? And then there's people, I don't want it to be a pillbox either, you know what I mean, with little holes in it. I don't think that's right either. I think, you have to look at biomimicry, where people want this connection to nature, right? So you can't get rid of glass. And I could say, like in the office I'm in now, they did a great job of making sure that everybody has not everybody, almost everybody has a connection to the outside to be able to get natural light. Okay.
Thanks, Al. The next question is about confusion between net zero and energy and carbon. They're asking, should we try to separate and allow net zero to be energy and then use carbon neutral? They're just trying to avoid people thinking that net zero energy is going to be net zero carbon. What are your thoughts?
Oh, well, yeah, you're probably right. It's kind of interesting. I had a client just recently talk to me about, I want to get my building to net zero. How many solar panels do I need to put on the building? I go, and I won't mention the facility, but we did a quick analysis, and I basically showed this owner that not only the roof of his building wasn't enough, the roof of the parking garage adjacent to it, if we used all of that, wasn't enough, and someplace else. And I said, you now have to reduce the amount that you're using. I think that's the first thing. And I think that where we have to do a better from our side, when I mean ours, I'm talking about the engineers out there, the architects out there, and the energy planners out there, to explain to owners and developers that, net zero energy meaning is one thing, but net zero carbon is something completely different. and maybe we have to come up with a different term, and I don't know what that is, and I'll kick it around with some friends that I know. I'm not saying that I'm going to be the one that's going to come up with the right answer, but it's a good point, because I think people are going to mix them up, and it's a reasonable concern. I know I didn't answer your question properly. I tried the best I could.
Thanks, Al. A question from an EMA member, actually. How do you replace gas-fired central plants serving large campuses with electric heating sources? It would be extremely difficult to impose high electric kilowatt sources in such applications. Do you have any experience there?
No, and I think you're right. I think, again, this is where, again, I always go back to what my dad, rest his soul, told me. He told me, Albert, there's nothing common in common sense. And the question that the person asked is a very common sense question. How do you do it? Well, it's really difficult in plants that are feeding a bunch of campuses that are may be energy hogs as they are. So being able to do it, you may not have enough electrical infrastructure to be able to convert that building. So in that case, I would say you come up with a master plan. This is, the energy management guy in me would say you do two things. You come up with a master plan. Master plan one is to make the plant that you currently have as efficient as possible, whether that's going with a series of smaller boilers that you can only burn what you absolutely need, tune your retro commission, your entire domestic, your heating loop to make sure it's operating as efficiently as it can, and then go to building by building by building and make them as energy efficient by putting better insulation, maybe if it's time to replace glass in them, and make them, more efficient as you, for any reason, if you're going to reduce the building, and I would say, unless the building is in bad shape, I would say renovate it so you're not, causing any more embodied carbon than you need to by new systems going in, but make it a more efficient building and start reducing it down. And maybe then you can think about going to heat pumps. So I think it's, I pointed out a solution, but it is clearly, the engineer in me is saying you gotta crawl before you can walk, before you can run. And I think we're just getting there, and everybody's at different stages of that evolution, if you will. Sam? Sorry.
Thank you, Al. So this next one seems like a common one, so I'm going to click it. And I apologize if we don't get to answer everyone's questions. There's so many, which is awesome, but we're just running a little bit out of time. So the next question is, this is it. Without major upgrades of the electric grid, is it irresponsible to switch more energy load from GHG sources, natural gas, coal, heating, oil, etc., without being able to support this fuel switching?
Oh, yeah, I agree with that. I wholeheartedly agree. I think one of the things that I think we start to see that is the plants, the power plants are highly inefficient as they are. If you start to think about it, if we not stay away because it's a bad thing, because you can't do that many of them. If you look at hydroelectric as being the most efficient way to make energy, and that is 85% efficient, right? To the next thing down on it, which is basically 49 or 50% efficient, which is the use of natural gas. So think about this. In plain numbers, for every 1 kW of energy that you're using at the site or at the building itself, and again, I'm talking simple numbers here. You need 1 kW there. You got to use 2 kW of it at the plant, right, in natural gas. However, we find why do most utility companies give you rebates or give you cheap electricity for commercial, and it's not everywhere, but in a lot of places to use thermal storage, right, to offload, to go on peaks and off peak energy. Because plants are more efficient if they're highly operated. So what they find is at night, if they can load the plants up more, they can do it. So there might be a strike. I just think we need to have, everybody needs to stop being polarized by this topic, and I'll say get in a steel cage match and discuss this, and all get everybody on both sides of this get together and figure out how to best do it, and that's how we'll fix that.
Thanks, Al. I think we have time for maybe two more questions.
Okay. Yep, I'm willing.
Let's do one more.
Sure.
Someone is asking about practical challenges of designing and building a new electrified facility in colder climates. Are there cost increases because it's cold? Market availability? Just asking for any experience that you have.
Well, unfortunately, while I'm a Brooklyn boy, and I profess that many times, but I've been in the South way too long. But I would think that going to all electric buildings in colder climates is going to have a challenge, based on, if you go back to one of the questions we had earlier, where it says, what happens when you get the real cold? How do you get heat out of the air? I think as those start to issues start to be overcome, because think about it, anybody that's up in the Great Lakes area or in the Dakotas, it gets down to below zero a lot of the time. So to say we're going to go to a heat pumps, and that is the panacea of be all, is foolish in thinking that. I just think that where things make sense, we have to do it. Where things, until the technology or advancements get there, we have to build, but we should just build intelligently and think outside the box, color outside the lines, if you will. Be that adventurer, not do everything cutting edge, but that's why, with all the tools we have available. When I started, I did calculations by hand. And when we had computers, they would take, I used to start to do an energy model, and for a life cycle cost, and I turn it on at 6 o'clock, and it was done sometime in the middle of the night. And now you do it and it's done in 20 minutes or 10 minutes. And we complain that it isn't fast enough. But the point of where I'm going there is we have all the tools that we can not predict completely, but we can better predict how a building is going to operate, with the modeling tools of now being able to bring in the buildings that surround the building to know what has effect on buildings and so on. We can do a better job, and we can design our buildings more efficiently and better as we go along.
Okay, thank you, Al. That's all the time we had for questions. So thank you again for hopping on here and dedicating an hour to your time for us.
And last thing is, if you're interested in becoming an energy management professional, which I highly recommend, even though if you're a CEM out there, no offense, I think EMPs, we're there, and so come and join me and my buddy Bob, and we will in Atlanta at AHR. And Bob is also doing a quick a lecture on there also. So come on by, visit with us, sign up for the energy management seminar. Look forward to seeing you.
Thank you all. Have a good afternoon.